we were talking about linear programming, and we went to graph a system of linear inequalities to find the solution of a system, solve linear programming problems, and use systems of linear inequalities in linear programming to solve real-life problems. So using linear programming, I have an example here. A baker earns 15 cents profit per glazed donut, G, and 40 cents profit per jelly donut, J. If a customer wants to buy no more than a dozen donuts and wants to try at least one of each kind, what is the maximum profit the baker can earn? So first thing we got to think about is the constraints. So in this case, we want the constraints, and we're talking about glazed donuts and we're talking about jelly donuts. So what if we make the x-axis represent the glazed donuts and we make the y-axis represent the jelly donuts? And it says at the bottom here, wants to try at least one of each. So at least one of each kind. So in that case, we know that two of the constraints are the glazed donuts have to be greater than or equal to 1, and the jelly donuts also have to be greater than or equal to 1. The next thing that we can look at is there's another constraint. The customer wants to buy no more than a dozen donuts. So all the donuts combined, no more than a dozen. So they have to be less than a dozen. So we can write that one down as the glazed donuts plus the jelly donuts have to be less than or equal to 12. So now that we have our constraints here and we're going to be able to graph our feasible region, we have to look what we have. So we have 1, 2, 3, 4, 5, 6, 7. 7 is not going to get us to 12, what we need. So what we're going to have to do is we're going to have to count by 2s. So 2, 4 is right there, 6, 8, 10, 12. And same thing going up. That's 8. And that's 12. We don't have to graph the negative in this case because glazed has to be greater than or equal to 1, and jelly have to be greater than or equal to 1. So we're not worried about the negative values there. So in this case, 1 will be right here, halfway between 0 and 2. So that is going to be jelly is equal to 1. And then we have another one where we have glazed is equal to 1. So it has to be greater than or equal to 1, so I know I'm shading this way and shading this way. Then we have one more constraint to graph for the feasible region. And if we substitute in 0 for G, then the jelly has to be 12. If we substitute in 0 for jelly, then the glaze have to be 12. So we have our ordered pairs right there. And we can draw the line that connects them. So our feasible region is everything that's in between. So we got to buy at least 2 donuts, but we want to be less than 12. So we have to look at what are the vertices. So right here we have a vertice, and that is going to be at 11, 1. Here we have a vertice at 111. And here we have a vertice at 1, 1. So next thing we have to do is decide what our objective function is. So for this one, our objective function is, what is the maximum profit the baker can earn? So we want to find the maximum profit. So a baker can earn 15 cents per glazed donut. So 15 cents per glazed donut. And 40 cents per jelly donut. And this is going to be equation for profit, because that's what we want to find. So we're talking about profit of the glazed donut and the jelly donut. And we want to find which would yield the most money for the baker. So we only have 3 vertices to check, and we have those written down right there. So the first one we can do is 1, 1. So the profit for the glazed donuts So the glazed donuts in this case are 1, and the jelly donuts are also 1. So 40 times 1 is 0.40. 40 cents times 1 is 40 cents, plus 15 cents times 1 is 15 cents. So this is going to be a total of 55 cents profit if he sells 2 donuts, or she sells 2 donuts. All right, that was the first one. Next point that we have to check, and we can probably even tell what's going to be the max because they're the same, 111 and 11.1. So which gets more profit? Does the glazed donut get the most, or does the jelly donut get the most? Well, I predict that the jelly donut will get the most because you get 40 cents profit per jelly donut. So the 111 will be the one that gets us the most amount of money, but we have to check it anyway. So the profit, and you get 15 cents for the glazed donut plus 40 cents for the jelly donut, and we want to check 11.1. So 11.1 is going to be glazed 11.1. And then we get the profit for 11 glazed and 1 jelly is equal to $2.05. And the last one to check, so we want to check the profit for 1 glaze and 11 jelly. And we get the profit is equal to $4.55 for 1 glaze and 11 jelly donuts. So the solution to this one, we want to write out our answer. The baker can earn a max profit of $4.55 for selling 11 jelly